The next thing we'd like to be able to do with whole numbers, now that we can add them, we'd like to be able to undo addition, and that's called subtraction. So, for example, we'd like to be able to ask the question, 4 plus what equals 7? To answer this question, we'll use subtraction. That is, 7 minus 4 equals what? Right. This is the whole idea of subtraction. It's saying, what is the missing thing in an addition sentence? In terms of counts of objects, well, we have 7, and we'd like to subtract 4. So, we take this one away, this one, and this one. What's left is 3. And of course, 7 minus 4 is 3 does not come as a surprise. The interesting thing here is how we imagine this in terms of counts of objects. Just like addition, subtraction is hard to see in terms of points on the number line, so I'm going to go directly to thinking about vectors. And again, there are two ways we can come at this. First, we can think of subtraction as the missing thing in an addition problem. So we can draw out the vector 4, and we want the result to be the vector 7. So what we need to add on is this vector. What is that? Well, if we pick up the red vector and we move it to start at 0, we see that this is the vector 3. Right? Starts from 0, ends at 3. Right. That really is the vector that we want here. We can move it again. Starts at 4, ends at 7. Still the vector 3. There's another way we can think about subtraction in terms of vectors. We can think, well, the first number I see is 7, so I'm going to start by drawing the vector 7. And then, okay, well, I want the vector 4, but instead of adding it on, I want to take it away. So instead of drawing 4 going to the right, I'm going to draw it backwards as 4 going to the left. Now I'm going to pick that up, and I'm going to move it so that it begins right where 7 ends. So my vector 4, remember this is 4 backwards, begins where 7 ends. Where does it end? Here's my 3. 7 minus 4 gives me 3. Both of these ways of understanding subtraction are going to be a great help to us later on when we go to try to do subtraction to more complicated numbers. Here, again, we already know that 7 minus 4 is 3. The reason that we're talking about this is to gain insight into why subtraction works this way. One last thing to mention, what do we want to do if we want to subtract big numbers without a calculator? Let's say we wanted to subtract 8,025 minus 472. Well, we start out just like we do with addition. Not a surprise. Remember, we discovered that subtraction really is just addition run backwards. So we start out by lining up the digits. So 8 thousands, 0 hundreds, 2 tens, and 5 ones. we'll line up 4 hundreds, 7 tens, and 2 ones, and we'll subtract. And just like addition, we subtract right to left. Here in the ones column, we just have 5 minus 2, and 5 minus 2 is 3. That's no problem. But here in the tens column, right, if we just did this the same way, we would have 2 minus 7. That's not going to work, right? In the whole numbers, we can't take 7 away from 2. What we need to do is go out and get some more tens. So to get some more tens, we'd like to try to break up some hundreds, but we haven't got any hundreds. So what do? We go over another place and break up some thousands. Instead of 8 thousands, we only have 7 thousands. But when we break up 1,000, we get 10 hundreds, right? 1,000 is 10 hundreds. So instead of no hundreds, we have 10 of them. Now we can break one of those up. Instead of 10 of them, we now have 9. But 100 is 10 tens. So instead of 2 tens, we have 10 plus 2 is 12 tens. So instead of 2 minus 7, we're taking 12 minus 7, which is 5. Okay, hopefully that won't happen again, right? Remember, in the hundreds place, we now have 9 hundreds. So 9 minus 4, that's 5. And 7 minus an invisible 0. 7 minus 0, that's 7. We get 7,553.